Hi, my name is Ken Altena. I'm a global black belt here at Microsoft, specifically dealing with HPC for the FSI industry. Today's topic is going to be integrating HPC Pack with Azure Files. First, we'll be covering HPC as a general topic, specifically covering HPC Pack for those that aren't familiar with it, and then we'll be talking about the file share options that exist for HPC Pack. Microsoft's vision for HPC really is to deliver an enterprise-class HPC platform that you can deliver higher productivity depending upon whatever your workloads happen to be, whether they be compute or GPU, and give you the flexibility of choice whether you need a cloud-native image, cloud-native solution, or a legacy-type scheduled solution. From an HPC evolution point, we see most customers coming from an on-premise cluster, potentially bursting into the cloud, then delivering from an IaaS point of view, running on virtual machines, and then eventually migrating into a cloud-native solution, such as Azure Batch. Some of the key differentiators for HPC Pack specifically are, one, it's a fully Microsoft-supported solution. There is no charge for HPC Pack to run within your environment. It gives you a consistent experience from a user point of view, whether or not you're running on premises or in the cloud, and it has a pre-built native cloud orchestration layer for Azure. So no longer do you have to worry about shutting off your machines after your jobs are done. HPC Pack will do that for you. Some of my initial assumptions as I was running HPC Pack myself, or some of the customer conversations that I would have, would be just run it on a standard IaaS virtual machine, and the performance should be good enough. You stripe it across a bunch of disks and customers should be happy. My benchmarking exercise that I did showed me how wrong I was. Here are the default shares that exist within an HPC Pack environment. The two most common shares to move are the runtime data and the remote install shares. Those are typically the two shares, along with any application workload shares, that are having to be the most performant. There are other shares within the environment, but typically they're less utilized and less needed to be highly performant like those two other shares I talked about. In terms of data usage, typically we see HPC Pack or any HPC workload as a read-heavy workload, especially as models are loaded on each compute node at the beginning of the run. Sequential writes typically happen at the end of the run, but those typically happen over a prolonged period of time by many different nodes. But the initial run is typically very read heavy and very bandwidth and latency sensitive, especially for the SMB protocol. However, just like anything else that exists within the HPC world, there are no stereotypical type workloads, so make sure you validate your own environment for what your own data usage happens to be. What are my options within HPC Pack for hosting this file shares? Well, like I mentioned before, you certainly could run this on an IaaS Windows file server hosting the file share. Gives you the ultimate flexibility of choice. You can design and craft your environment how you might have done on-prem. But again, within the cloud, there are various different limits that have to be accounted for, not only from a networking limit, but also disk limits and performance limits. So it may be more difficult than the standard Windows administrator would want to deal with. So that led to a growing number of software appliances that exist within the Azure marketplace. Some of them I listed on the screen, but as being a third-party service within the marketplace, that gives you the need to potentially contact them as well as Microsoft for support. And the performance was across the board. My greatest recommendation as you're evaluating anything within the marketplace, especially for hosting SMB workloads, is to make sure that it supports SMB multi-channel. The most popular support item at this time happens to be Azure NetApp Files. It's a first-party Azure service, so there is only one stop for your supporting this platform. It offers a rich ecosystem with solutions for backup, replication, as well as cloud sync solutions from back on premises. There are 3 performance tiers, standard, premium, and ultra, to design your environment to hit the performance tier that you need. It also offers easy integration with on-premises Active Directory services. Let's talk specifically about Azure Files. What changed with Azure Files Premium that makes it more interesting for this workload now? One, it offers support for on-premises Active Directory services. So I can bring my on-premises identities without having to replicate them into, say, Azure Active Directory and provide them access to these files. By offering the default share permissions, which we'll talk about later, it prevents us from having to do the Azure Active Directory Connect, or also offers support for some complex forest environments that may not have been applicable in the beginning. It now also offers SMB multi-channel to provide higher level performance. We also offer increased performance by now offering bursting IOPS and bursting bandwidth to provide a best-in-class performance across the board. So Azure Files at a glance. Let's take a quick look at an overview of it. One, it's easily managed. We're offering it as a service, so no longer do those limits on inputs and outputs necessarily exist. You design both bandwidth that you need, the IOPS that you need, to the capacity that you need. It's cross-platform, supports SMB, NFS, clients from Windows, Linux, and Mac, both on-premise, in the cloud, or from anywhere you need the access. From a security standpoint, it offers encryption both in transit and at rest for SMB protocol. And it's hybrid oriented. It natively integrates into the Azure File Sync solution to support synchronization of your data from on-premise into the cloud and back. From a workload perception, this really should be able to satisfy the workloads, whether they are SQL, HPC, databases, or general file services. Whether the access is from an NFS client or an SMB client, whether it remains on premises or in the cloud or even outside my network, Azure Files offers you a place to mount that share into your resource. From an Active Directory integration perspective, we've removed the requirement that you needed to implement Active Directory Connect to replicate your identities into Azure Active Directory. It offers simpler management utilizing ACLs or typical NTFS management. Now, the Active Directory Directory Services does require line of sight to a domain controller. However, no longer do I have to, say, replicate every single forest that domain controller needs to be accessed. And enabling Active Directory integration is through an easy PowerShell command. From a multi-channel, it's enabled by a simple flip switch. It's not enabled by default. However, there is no reason not to enable it. Offers increased IOPS, 3 times the amount of IOPS. Offers multi-threaded access to single files or multiple files, and increases the throughput on the read side 2 times and on the write side up to 4 times. From a cost optimization perspective, you're able to reach higher scale with fewer clients. So let's go through the benchmarking that I did. As I evaluated both the on-premises solutions, the various different first-party Azure solutions, I utilized the open source disk speed tool. And you can see on the screen what commands I utilized, modeling that sort of generic HPC workload that I talked about. That was read heavy, very much randomized IO, and very much large IO blocks. I ran the command 3 times on every client and averaged the results. Where the results from a single client didn't meet the expected performance of that share, I expanded that until it did and marked how many clients it took me to achieve the expected bandwidth. From a client SKU perspective, since each client is also limited in terms of networking and disk communication, I evaluated both the D64AS series V4 as well as F64S V2s. I evaluate the performance from a single availability zone and from multiple availability zones to determine if there was an impact if I was in a different availability zone than the share exists. From a recommendation perspective, I did run the command 10 minutes of random IO to the drive first. And in doing that, I did see a 30 to 40% improved performance. Now, in reality, you would be running random IO consistently against this share. So I wouldn't expect that to be something that you'd have to do on a routine basis. This was only relevant for benchmarking. And I required to write against multiple targets to get optimal performance. And we'll see the difference between when I did and when I did not. So here's the benchmarking results. And I realize this is a spreadsheet, and you may want to pause this video to actually digest what the benchmarking results is. If you do want to see it online, I do have a tech community blog article in which I share the same results out there as well. So from the benchmark, what are the takeaways? What were the lessons learned that we did? First, Azure Files Premium was the most cost-efficient first-party file service when considering bandwidth. You can see in the slide below that Azure Files Premium, when compared to Azure NetApp Files Premium, was as performant at 25 terabytes, but from a price per bandwidth was only $2.30 per megabytes per second, where Azure NetApp Files Premium was $4.59 per megabyte per second bandwidth. Now, these prices are list prices. Your prices may differ based upon what region you're implementing and what discounts you might have had. Azure File Standard, however, is perhaps the most cost-efficient option for maybe your sandbox or your development environment in which the level of performance is less needed and where the focus is more on cost. Azure NetApp Files, however, had the highest level of single file performance and the highest single client performance in the benchmarking exercise. However, as you can see, Azure NetApp Files had the highest single file performance as well as the highest single client level of performance in the study. As we look at the impact to SMB multi-channel and targeting multiple targets versus a single target, you can see where enabling SMB multi-channel made a 50% difference on single file performance between 409 megabytes per second going to a single file to 617 immediately after I enabled multi-channel. However, immediately when I started targeting multiple different targets on the same share, it immediately increased to well over 2.3 gigabytes per second. So you can see the importance of having multiple targets or writing to multiple different files within a single share. Thank you for listening. I hope you indeed check out these links that I provided and evaluate for yourself whether or not Azure Files Premium could indeed host your HPC shares. Make sure you check out the blog article I mentioned that will be tagged below, where we go into the details more fully. Thank you so much for your time. Have a great day.